All right. So, um, this is part two of 02, operations with complex numbers. And we talked about adding and subtracting last time. This time we're going to look at multiplying and dividing. So, multiplying complex numbers is going to be similar to multiplying polynomials. Remember polynomials, that's where you have those parentheses, those groups, right? You have like x plus 7 and 3x minus 9 or 10. And then to multiply those, um, you want to do FOIL, but not just FOIL. You want to kind of distribute each of these terms on the left side to each of the terms on the right side. And then you have to add those together afterwards, right? So we're going to be doing the same thing, but this time with complex numbers. So let me save this really quick. All right, so let's look at these. So here, um, the first one is where we have 18. Let's do 18. Now, if you remember the formula for squaring a binomial, remember that's going to be a plus b squared is a squared plus 2ab plus b squared. All right, so it's the same thing. If you want to do it that way, you can do negative 2 squared. Oh, this is your a and this is your b. And then we have plus 2 times negative 2 times negative I plus negative I squared. And there we get 4, and then 2 times negative 2 is going to be negative 4 times negative I is going to give us positive 4I. And then here, negative squared is going to make it a positive, but I squared makes it negative 1. And there we have 4 minus 1, combine like terms, we get 3 plus 4I. And that's it. Now you could do it that way. If you remember that formula, it's really good if you do memorize that formula because it's not too bad. Square the first, multiply the 2, and then times 2, and then square the second. Okay. Now, if you can't memorize that formula, that's okay. Let's look at 20. You can also just separate that squared because squaring is just multiplying it by itself. So sometimes when you can't think of the formula, as long as you remember this, you're good. All right, it's gonna be okay. So same thing, FOIL, 5 times 5 is 25. 5 times 2i is gonna give us 10i. And then 2i times 5 is 10i. And 2i times 2i is positive 4i squared. All right, so now we combine like terms. 10i plus 10i is 20i. And remember, the I squared is just negative 1, so it's going to be 4 times negative 1 or negative 4. So 25 minus 4 gives us 21 plus 20i. And that's it. Okay, so that's how you do 20. And then everything else is the same. So yeah, just feel free to try them. Let's do some that aren't squared. Okay, let's do one with a plus and a minus. Why not? Actually, let's do that one later. Let's do 24 first. We have 5 plus 3i times 2 plus 6i. All right, so same thing. You could do FOIL. First, outside, inside, last. That is how we multiply. Okay, so 5 times 2 is 10. And 5 times 6i is going to give us 30i. And then 3i times 2, and then 3i times 6i. So 3i times 2 is 6i, and then 3i times 6i is 18i squared. Yeah, don't forget that squared. And then 30i plus 6i is going to give us 36i plus, and then that I squared becomes -1. So 18 times -1 is just -18. So a 10 minus 18 is -8 plus 36i. Ta-da! That's it. All right. So there you go. Now let's do one of these, like 23 or 25. Notice that we have 3 plus 5i. Here we have 3 minus 5i. Here we have 6 plus 7i, 6 minus 7i. So it's the same numbers, but different signs. Now, the reason why they're showing that now is because we're going to be doing it for division. So remember, these are called conjugates. Conjugates. So the same numbers, just different signs. One is plus, one is minus. Okay. And why is that? Because we get something cool called the uh, sum and difference. Okay. Difference of squares, that's what we'll end up with. And you'll see that here, as soon as I can choose which color, I'm just going to write it down first. So this is difference of squares. Okay. Sorry, this is sum and difference. All right, so same thing. 3 times 3 is going to give us 9. 3 times -5, -15i. And then, oops, 5i times 3 is 15i. And 5i times -5i is -25i squared. Now notice how we get a -15i and a positive 15i. Yeah, that's always going to happen because these are conjugates. Okay, because one is positive, one is negative, and the numbers are the same, so they're going to end up being opposite numbers here. So they always cancel out. Hey, and we're left with 9 minus, and that's 25i squared. So I squared is the same as -1. So it's the same as plus 25, which is 9 plus 25 is going to give us 34. And that's it. Okay, so we're going to be using conjugates later on. Okay, so feel free to try the others if you like. It's good practice. Let me save this, put it on the notes. Oops. All right, so we did multiplication. Now we're going to divide. And here we do need to know about complex conjugates. Okay, So we saw it in Algebra 2, where we had radicals, okay? I'm just kidding. Where we had rational numbers, okay, rational expressions, okay? So where we had like x minus 7 and over yeah, 3. No, x plus 1. Let's do that. So we saw it there in Algebra 2. We're going to see it again later on in Precalc. But the way to solve this one is not solve it, but the way to simplify it is you want to multiply the top and the bottom by the conjugate of that denominator. So it would be x plus 7. So same numbers, but different sign. And notice you multiply top and bottom because that's 1. So it's just like multiplying by 1. Okay. And then you'd end up with x squared plus 8x plus 7 over, and then you get x squared minus 49. Sorry, tired. Hmm. Okay, well, there you go. I think I did it with. Okay, we're gonna see this with rational, um, with radicals. Okay, but these are conjugates. That's the main thing that you need to know. Okay. All right, so here we go. And the reason we can't have these in the denominator, the i's in the denominator, is because I is a radical, and we can't have radicals. We can't have that radical in the denominator, right? So here, I should have shown you one with the radical. Oh well. Let's do this. Let's start with 26. So you want to look at the denominator and multiply the top and the bottom by that denominator. Not just any denominator, you want to multiply it by its conjugate. And I'm going to put parentheses here because we are multiplying by group. And if you want to technically you should put parentheses around everything just to make it um, uh, accurate. Okay, now let's just focus on the top. So focusing on the top, we have 5 times 6 is 30. 5 times negative I is negative 5i. I times 6 is 6i. And I times negative I is negative I squared. All right. And then if you want to simplify that, you get, remember this is negative negative 1. So minus negative 1. So it's the same as plus. So 30 plus 1 is 31. And negative 5i plus 6i is plus 1i, or just I. And now we're going to look at the denominator. So here, remember from that previous example that we did where we multiplied conjugate binomials, you just want to multiply each. So here we get 6 times 6 is 6 squared. And then I times I, and it should have a minus in between. It's going to give us I squared. Multiply those, and you get 36 minus negative. Oh, this is negative 1. So 36 minus negative 1 or 36 plus 1 is 37. If you're wondering, Mr. T, how come you didn't do FOIL here? How come you didn't do this like this? Okay, the reason why is because, remember, they're the same. So here, if we did 6 times negative I, we'll get negative 6I. And we do I times 6, we'll get positive 6I. So because they are conjugates of each other, these are going to cancel out. And we're left with only the outside terms. Okay, now if you want, I can show an example. I can do the whole thing. Okay, maybe I will. Yeah, why not? I'll do 30. Yeah, 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 let's do 30. Okay, let's use a different color. Purple. Here we go. So we're going to multiply by the conjugate. We have, so just like the denominator, except plus. Change the sign. 2 plus 3i. 2 plus 3i. All right, and what do we get? So you get 1 plus 2, sorry, 1 times 2, and then 1 times 3i. You get 2 plus 3i, and then 2i times 2, 2i times 3i. So we get 4i, and 2i times 3i is 6i squared. And remember, this is -1, so that's the same as -6. So 2 minus 6 gives us -4. And 3i plus 4i is 7i. That's the top. That's the numerator. And here we have, oh, so I said I was going to do the whole thing for this one. Okay, but remember, all you need to do is just do the first one squared minus the second one squared. Okay, that's it. First one squared minus the second one squared. But I'm gonna show you both. Okay, I'm gonna show you the longer way. So 2 times 2 is 4. 2 times 3i is 6i. And then 3i, negative 3i times 2, and negative 3i times 3i. So negative 3i times 2 is negative 6i. Cancels out, right? And then negative 3i times 3i is negative 9i squared. So again, that is a -1. So -9 times -1 is +9. 9 plus 4 is 13. And 6i minus 6i is 0. And that's what we get. If you want to split it up, you can. I think the book does split them up. Do you need to? I think because they do like to separate the real term and the imaginary term, that's why they usually separate them. Okay? But just know it's the same thing. And that's it. Any questions? No, just kidding. All right. So let's look at one of these with the radicals. Again, radicals. It's okay. And this is going to be the last one, I think. Ooh, they have completing the square. Maybe we should do completing the square just for fun. Yeah, I don't know why I put an equal. All right, so here, multiply by the radical. Sorry, multiply by the conjugate of the denominator. So that's the plus, so we want to make it minus. So 3 minus square root of 6i. And notice that the I is not inside the inside that square root. Okay, it's outside of it. Why didn't I change the color? There you go. 3 minus square root of 6i. So here we go. 2 times 3, 2 times negative square root of 6. So you have 2. No, 2 times 3 is 6. Hey, there you go. 6, and then 2 times negative square root of 6i is 2 square root of 6i. And then negative square root of 2i times negative square root of 6i. They're just making it difficult, just for fun. Okay, negative 3 square root of 2i. You can't multiply them. You can't combine them because the 2 is inside that radical. But then the 2 and the 6 we can because they're both inside radicals. So square root of 2 times square root of 6 is going to give us, oh, a negative times a negative is positive. So square root of 12i. And we can actually simplify that to a 2 root 3. If you want, we could do it later. All right. And let's just right down here. So this is, oh, this should be squared. Sorry. Remember, this is a negative 1. So it's going to be 6 minus square root of 12. Or if you want to say 2 root 3, you can. Okay. And if you want to know how to change that to a 2 root 3, just let me know. And I'll make a video. Or we'll go over it. And then the i's, we have a square root of 6 and a square root of 2. Because those are different radicals, we cannot combine them. So we just leave it like that. Minus 2 root 6i minus 3 root 2i. I. It's a lot of i's. Ah, we could do this though. You could write it in groups. So it could be 6 minus square root of 12. And over here, plus negative 2 root 6 minus 3 root 2i. You could write it like that. Okay, so that way you just have one I. So you're just factoring. Okay, because they both have an I in common, so you just factor out the I. Okay, so there's that. And that's the top only. Oh boy. On the bottom, just square it. So square the first term. Our first term is 3 squared. It's going to give us 9. And square the second term. Just square root of 6 I squared. And square root of 6 squared is 6. And then I squared is going to give us negative 1. Remember? And you want to put a minus sign in between because difference of squares. So we basically have 9 minus negative 6, or 9 plus 6 is 15. And there you go. Whew. So that's that. Am I going to give you one like that? Of course not. Why? Just the regular ones are fine. That's just extra work for no reason. Okay. And here again, electricity. So complex numbers is similar to, or you use similar um, properties for solving electric stuff. Here we're talking about amps and ohms. Oh my goodness. Okay, so let's look at this one. These are, oh, I thought it was completing the square. Okay, These are not completing the square. This is just solving for x. So yeah, there's nothing to these. You just want to get the x by itself and then square root. All right, so here we subtract 5 on both sides. You get 5x squared equals -5. And then divide by 5. And you get, that's why they put these here. And you get -1. And then you square root both sides to get rid of that negative. To get rid of that squared. And whenever you square root both sides, you need to put plus or minus. Whenever you square root both sides, you need to put plus or minus. Unless you're talking about distance, because distance is just positive. Okay, but here we have plus or minus, and the square root of 1, we know that as I. I. There you go. And let's do 40, I guess. Yeah. So let's do one that's not an I. Well, it's going to have I in it, but it's not going to be just I. So here, subtract 12. You get 2x squared equals -12. And then divide by 2. You get x squared equals -6. Square root both sides to get rid of that squared. And remember, when you square root both sides, you need to put plus or minus. And you get x equals the square root plus or minus. And so this is technically -1 times 6. -6 is -1 times 6. And what's the square root of -1? That's I. So here you would get x equals plus or minus the square root of 6. And that square root of -1 becomes I. And the I always comes last. So it's just the way we write it. Okay. Math is very humble, right? I always go last. No, you go first. See? All right, there we go. If you have any questions, feel free to ask.